Okay, 349. So we're going to talk about the inheritance of those two diseases we just talked about, color blindness and hemophilia, as examples of sex linked. So let's just review real quick what we talked about. So the X chromosome is bigger than the Y chromosome, right? And a female can basically have the dominant form or the recessive form of a disorder or a disease. I mean, I don't really think of color blindness as a disease. It's more of a, you can't see perfect. She could also, right? She could also be homozygous dominant. That's also possible if the genes are located down here. And it's also possible that she could be homozygous recessive. And in that situation, she would have color blindness. So color blindness and hemophilia, both of them are controlled by recessive alleles. However, the male, there's only two situations he can be in, right? He could have a dominant form and nothing, or the male could have the recessive form, which would make him colorblind since it's recessive and he has no chance to fight it off with a dominant form. So let's talk about those real quick. So there's a special way that we do the notation. So for males, actually males and females, we actually write the chromosomes X and Y down, and then we put the letter B, in this case for color blindness, up top. So male could be this, and we would call that unaffected. Want to stay away from the word like healthy, but he's just unaffected. It's because somebody's still healthy if they're color blindness. Or the male could have the recessive form, right? And that would be affected. Or you could say that this individual male is colorblind. So that is how we note the males. And then for females, same deal. We write the X's. So female can be homozygous dominant. That is unaffected. She is not colorblind. She could be heterozygous, right? She could have a B and also a small b. That's unaffected. And in this situation, when we talk about carrying ailments, diseases, or some sort of chromosomal abnormality, we say the individual is a carrier. So that was one of the definitions from way back on slide 3.41. So this is a carrier. She's secretly carrying it, and we don't know because her vision is perfect. However, she's carrying that allele. And then last, if she has two recessive forms, she would be affected or she would be colorblind. Both of those are fine. So let's do a cross real quick. So I'm going to erase all of this. I need a bigger eraser. And let's cross a heterozygous female with an unaffected male. So that'll be our test cross. This is taking longer than I thought it would. Okay. So we'll make our Punnett cross like this. And we said a heterozygous female. So she will have one X chromosome that has the dominant form. We could also call her a carrier, right? And she'll have one X chromosome that has the recessive form. And the male, we said he's got healthy vision. He's unaffected. So he has the dominant form. And on the Y chromosome, we put the letter, no letter, right? We leave it blank because there's nothing to put. And then we do the cross. So if that X meant that X, right? Those two gametes met, you'd have a homozygous dominant, so that'd be a healthy individual. If this and this met, we'd have a heterozygous carrier female, a daughter. In this situation, an X with a big B and a Y, that would be a male with healthy vision, unaffected. However, if this met the Y, then you would have a son with color blindness.